Here is the last section of our, top 6 most common topics on Algebra 2. As you can see, I've changed it from top 5 to top 6 because probability and statistics has become increasingly more prevalent on the Regents. So I want to make sure that we are prepared for all of those types of questions. So again, using the January 2023 Regents, we're going to look at a couple of questions that involve probability and statistics. And we're going to talk about each one individually to make sure we are all on the same page. Okay, so question 14 is an example of one of those common sense type of questions. It doesn't really require too much math, but you do need to understand what it means to be biased. So in math, in order for something to be biased, or in order for a study to not be able to give conclusive results, something might be skewed, whether that's the population that you're choosing from, how you collect that information, a problem in the questions that you're asking. There could be a number of things that cause our results to be skewed or not representative of our population. So this question's basically asking just that. Which statement about data collection or how you collect your information is most accurate? So the first one says, a survey about parenting styles given to every 10th student entering the library will provide unbiased results. Okay, now everything in this question sounds great, right? Every 10th student, right? Being at a place where students are found of all types sounds great, but what are they asking about? Are they asking about the library? Are they asking about students? No, they're asking you about parenting styles. So it would not really be a good representation of the population to ask students who are most likely not parents about parenting styles. I mean, some can be parents, but not all of them are going to be parents. So this would create biased results because they are only one sector of the population. They are not necessarily even the full population that they're asking about. So I would say this is not great. Choice 2. An observational study allows a researcher to determine the cause of an outcome. Now, observational study is literally when you are just making observations. You can only watch. You cannot interfere with the people or subjects that you are studying. So that means if I'm sitting in my classroom and I want to know what kind of ties the boys are wearing, I need to observe from afar. Just look, make my notes, and then make some conclusions later. Now, can I say that it being Wednesday causes students to wear purple ties? No. I can say students are likely to wear purple ties on Thursday if I'm observing that, but I cannot define a cause. Okay? Now, typically, the most likely you are to find a cause is with an experiment. It doesn't even mean you're definitely going to find one, but it is your best chance of actually seeing some cause and effect. For instance, if you're seeing if sunlight helps a plant grow, you keep everything the same. One plant gets light, one plant does not. We can see if it causes it to grow. The sun causes it to grow. So, can an observational study allow a researcher to determine cause? No. It can help you understand a population, but not really talk about the cause. The next thing they talk about is the margin of error, which the margin of error increases as a sample size increases. Now, margin of error, the informal short way we talked about it, was that it is basically the value 2 times the standard deviation. Now, with 2 times the standard deviation, right? Standard deviation is how spread out your values are. I can have a list of 1,000 numbers, and it can have the same standard deviation as a list of 100 numbers if the numbers are basically around the same distance apart. So the sample size or the number of participants is not going to affect the standard deviation, which also is not going to affect the margin of error. So that means option 4 has to be our answer, but let's see why. A survey collected from a random sample of students in a school can be used to represent the opinions of the school population. Well, if it's random and it is students in that particular school, you will have representation of that particular population. So, yes, I would absolutely say as long as the people that you are collecting represent who you're trying to find out about and you are finding it in the most random way without any bias towards one population or another, you are going to get a good sample size. Again, these are common sense questions in a sense. You do need to know what an observational study is. You do need to know the marginal error. You do need to know what a survey is, but a lot of it will be about how you interpret it and how you can prevent bias from occurring. Now, question 19 on this is one of those simulation questions. You all know my opinions on these simulation questions, but we're going to take it one at a time. Betty conducted a survey of her class to see if they like pizza. She gathered 200 responses, and 65% of the voters said they did like pizza. Betty then ran a simulation of 400 more surveys, each with 200 responses. Assuming that 65% of the voters would like pizza, the output of the simulation is shown below. Okay, now, what are these dots? Each one of these dots represents somebody from the sample set. So of the 400 more surveys that we have in the question, right, there should be 400 dots in this section. I'm not going to count it, but that is what should be occurring here. Now, you see the word proportion. That is basically asking the proportion of students who voted or decided that they liked pizza. So that's why they're decimals, because what they really are percentages, right? 65% is approximately in the middle, 75% to the right, 75% to the 55% on the left. Now, the standard deviation of these proportions is also listed in the corner. It is a 0.035. We know that we can use that standard deviation to help me find a 95% confidence interval, right? To find a 95% confidence interval, you are going to take your mean and you are going to add 2 times the standard deviation and subtract 2 times the standard deviation. This is going to be your upper bound, and this is going to be your lower bound of this interval. So this question says, considering the middle 95% of the data, what is the margin of error for the simulation? Well, as I stated above, margin of error is going to be 2 times your standard deviation. And so when I take my calculator, I'm really multiplying 2 times in this question, 0.035. which works out to be 0.07. Now, we can also use this 2 times standard deviation to help me find my 95% confidence interval, right? Because if I take my mean of 0.654 and add this margin of error, I get the upper bound of what a typical value would look like. So it would not be surprising to me to see a value as high as 72.4%. It shouldn't surprise me because that's what the margin of error does. It allows me to create a range of typical values. Same thing here. If I take my 0.654 and subtract my margin of error, 0.654 minus 0.07, I get 0.584, which again means that it is not surprising if I see a value as low as 58.4%. Okay, so my confidence interval is between 58.4 and 72.4, and anything found in that interval is a typical value. It is verifying the conclusion that we made, and that's all using the margin of error, the amount of error we are allowing when collecting our information. So those first 2 questions give a good idea of the types of statistics questions. They'll either ask you about how to collect information or about these simulation questions. But they can also ask us about probability. Now, anytime we see P of A, P of B, P of A and B, we need to know about probability. Now, I have posted onto Blackboard a probability formula sheet that gives you an idea of some of the things that we need for our regions. Okay, so you have up there just the basic probability of an event, the complement of an event, so basically that an event is not happening. Probability of A given B, which is our conditional probability, which is basically saying the probability that A happens given that B has already occurred. Okay, we also have our OR probability expression, which is basically the union of two sets. So basically we want to consider everything in the particular set and add them all together. So when we see an or this symbol down here, AUB, which is the intersection symbol, the union symbol, we are going to add probability of A, which is one full circle, add probability of B, which is the second full circle, and then deduct anything that I have counted twice, aka the overlap. Okay, so this formula can be used to find A or B or A union B, and we can actually solve a little bit to find A and B if necessary and if they've given you the right pieces. Now, the other thing they love to ask about is if things are independent. Now, if things are independent, basically one thing does not affect the other. Okay, so if I have a grade of 60 in math and a grade of 70 in English, right, I want to know if those two things affect each other, if one thing affects the probability of the other. Okay, so if they are independent, you can actually find the probability of A and B occurring, the probability of both things occurring, by multiplying probability of A times probability of B. If it is not independent, we don't have that flexibility. We can't just multiply probability of A times probability of B because there's overlap. So in order to do that, you're going to find A and B, you're going to take the probability of A and then multiply it to the probability of B given that A has already happened. Those are the ones where we have to, let's say we pull out a card and we don't replace it. Right, we have to deduct from the numerator, deduct from the denominator, because we have to assume that A has already happened. Now, one question they love to ask is, are two events independent? And that's what these last two formulas are for. There are two tests for independence. The first test is if the probability of A and B is equal to the probability of A times the probability of B, we know it's independent. So something you can do is find both of those, all three of those probabilities, calculate what you need to calculate. If it is equal, they are independent. The second test, and the test that they tend to encourage you to use on the regents, is the following. If the probability of A given B equals the probability of A, then A and B are independent. What that means is that the probability of your first event happening is not affected by the probability of the other thing happening, right? Probability of A given B. So we're trying to see if those two things are the same so that we can decide if things are independent. Now, just like we have the union symbol for or, we also have this intersection symbol for and, right? Meaning at the same time. And so when we think about a Venn diagram, that's your overlapping areas. So looking at question 27, given probability of A equals 1/3 and probability of B equals 5/12, where A and B are independent events, determine probability of A intersect B. Okay, they want you to know these symbols. And we know it's independent, so I go to where it says independence. Okay, if it is independent, which we know, we're not trying to prove it, we're in this box right here. We know that probability of A and B, which from down here we know is A intersect B is equal to the probability of A times the probability of B. And so, what am I doing here? I'm multiplying probability of A times probability of B, which is just multiplying 1/3 times 5/12, aka 5/36. And that's it. Okay, so make sure you memorize these formulas, you know them, you understand them, because they can be asked in any combination of terms. And so if there are any other probability or statistical questions, right, make sure you take a look at those for the January 2023 Regents. Some of them are the ones we went over and others are new. And the last thing is basically we've only covered a fraction of the questions. It's a good fraction, but not all of them. Some other things you need to make sure you memorize and understand and practice are just basic exponential functions, right? How the exponents work, what the functions look like, etc. So that is question number 29. You're going to need those skills. You need to definitely remember synthetic division and remainder theorem because there's always at least one. And sometimes they really, really force you to do that remainder theorem. So you want to make sure you review that. There's always one question that has imaginary numbers, usually some sort of binomial that you have to multiply, and you need to know that I squared equals -1, so it's simplified. So make sure you know that. System of equations, always on the test. That is almost a graphing question, but sometimes they want you to solve. So make sure you know when to use elimination, usually those 3x3s. When to use substitution, usually the circles and the lines. When to use your calculator, that's when you see f of x is equal to p of x or g of x, whatever it may be. There's 3 ways to focus on that. And then, of course, other polynomial questions and quadratic questions. If you can't solve a quadratic by now, you're going to be in trouble. They are always a part of the questions, whether it's in a rational equation, a radical equation, or just a quadratic with imaginary solutions. They want you to be able to solve it. And last but not least, our trig. Make sure you review that. That was the last thing we talked about. I'm hoping and relying on the fact that you still remember it. If you don't, go back and check. Okay, and that is it for my top 6 topics. Happy studying.